There's a phase in between aneurysmal rupture and a second phase called delayed cerebral ischemia where the patient seems fine. And then all of a sudden, this devastating ischemic event hits.
Delayed cerebral ischemia is caused by a microvascular dysfunction. And this microvascular dysfunction reduces blood flow to the neurons.
We can actually, with a therapeutic, specifically target brain blood vessels and make them dilate and make them increase their perfusion.
This medication completely prevents DCI in mice. And the question now really is this drug equally effective in the human population? My name is Steffen-Sebastian Bolz. I'm a principal investigator at the Ted Rogers Heart Center at the University of Toronto.
My name is Darcy Lidington. I am a senior research associate at the University of Toronto, and I work very closely with Steffen-Sebastian Bolz.
When a brain aneurysm ruptures, you have free blood within the brain, in the subarachnoidal space. The free blood increases pressure in the skull.
The blood that spills into the brain cavity essentially squeezes the brain. And when it squeezes the brain, it stops the blood flow. That, of course, is rapidly fatal unless you immediately intervene.
And I had to learn that even if we treated them adequately by decompressing the bleeding in the brain and by emptying the blood, we had to be very vigilant because these patients started to drift into another part of the disease 4 to 10 days later, which is called delayed cerebral ischemia, and that actually has a high death toll.
This ischemia is essentially a blood vessel-based stroke. It is a key focus in patients who have had an aneurysmal rupture to try to fix this problem. For those who survive, it affects memory, decision-making. It's changed their personality, and everything in life becomes harder. Now, the problem that physicians and neurosurgeons face is that we know that blood flow is being reduced to the brain, but we don't really understand why the blood vessels are behaving the way they are.
What we decided from the start is to first understand the mechanism and then look for the treatment. Everything we did strategy-wise was to first go for the smallest arteries, dissect them, and study them in a controlled environment. What's very clear is that the brain is a very highly autoregulated vascular bed, which actually means that the brain very, very tightly controls blood flow. And this control is executed by the smallest arteries in the brain.
These very, very small blood vessels that are really the gatekeepers to perfusion of the brain actually get more constricted when they're exposed to inflammatory mediators. And so over the last 10 years, we've been trying to figure out why and how this occurs at the molecular level. We found a key aspect that solves two very important problems. One, we found a drug target that will make these vessels dilate and therefore increase perfusion. And two, it only seems to be a mechanism that's in brain blood vessels.
This drug that we're going to repurpose works in mice. In a mouse model of subarachnoid hemorrhage, we can prevent delayed cerebral ischemia and all the subsequent symptoms. So these mice have much better neuronal health, they have much better cognitive function, they have much better learning behavior, and so on. It could really change a lot of patient trajectories.
To go into a new direction, to take a chance, it's very difficult to get that funded. And this is where the Brain Aneurysm Foundation plays a really key role, because it allows researchers to open up a new direction and push in sort of an area that hasn't been investigated before, because there might be gold there.
Every of the Brain Aneurysm Foundation grants we got helped us to open a new door. It helped us to open a new funding stream, and it helped us to follow new ideas.
We've been able to collect data with these grants and then get larger grants from other organizations because we have the data to say this direction we're going is not crazy,
What is unique about the Brain Aneurysm Foundation is what I call the human touch. Is this mix of meeting people you have common interest with.
It brings us all together in a family-like environment. So it brings families of people who have suffered from aneurysmal ruptures, and they're the ones that are supporting the research programs. It brings the researchers together, and it's really a family event where we're all striving for the same goal of improving the outcomes of people who suffer from aneurysmal ruptures.